Hello, good day everyone. So today we are going to do some balancing of the chemical equations. So I hope your pen and papers are all ready. So before doing the balancing, we will be discussing first the four golden rules in balancing chemical equations. The first rule is the law of conservation of mass. Matter cannot be created or destroyed. So the elements that you can see in the reactant side are the same elements that you can see in the product side. The second one is that subscripts cannot be added, removed, or changed. For example, we have the chemical formula CH4. The 4 here is the subscript. Since it is the subscript, we cannot change it because it is already given in the formula CH4 for methane. But the only thing that we can change are the coefficients. So the coefficients are placed right before the chemical formula. An example of this is the 2 in the 2CH4. Okay? They are always placed before the chemical formula, and they are the ones that can be changed because the coefficients are the main character in balancing chemical equations. So I hope that is clear for everyone. Another thing to consider are the extra tips in balancing chemical equations. I know that balancing chemical equations require creative problem solving strategies, and it's more on trial and error type, but we can easily balance chemical equations if we follow these extra tips. So the first tip that we can follow is to balance the big formulas first. So how can we know that that is the big formula in a chemical equation? We will look for the element that has the highest number of atoms. Don't be pressured. You'll encounter these situations later on. Second one, if the same polyatomic ions appear, I want you to note, appear on both sides of the equation, it's usually okay to treat it as one unit. Right? So here's a condition. You have a polyatomic ion, but same polyatomic ion must be seen in the product side. That's the condition for the second tip. The third one is more on creativity since some equations are harder to balance. Right, so let's proceed to some application of balancing. As you can see in the left side of your screen, I placed there the important information that you have to take note. The polyatomic ion chart. There are three of them. We have 1, we have 2, and we have 3. I also placed here the tips, extra tips to follow when we do balancing later. So we have tip number 1. We're going to balance big formulas first. And tip number 2, if the same polyatomic ions are found on both sides of the equation, then we're going to treat it as one unit. Alright, let's proceed to the first sample problem. So we have here an equation of CH4 plus O2 yields CO2 plus H2O. First things first, we're going to list down all the elements present in the chemical equation. But first, in the reactant side. So we have here carbon, we have hydrogen, we have oxygen. In the product side, we also have the same. We have carbon, we have hydrogen, and we have oxygen. The second step that we're going to do is to count the number of atoms present in each element. So starting with carbon, we only have in carbon, we only have 1. So don't be confused if you cannot see any subscript under one element. This means that it only has one atom. So we will place here 1. In hydrogen, according to the subscript, there are 4. Sorry, there are 4. For oxygen, according to the subscript, you have 2. Let's now proceed to the product side. For carbon, you only have 1. For hydrogen, according to the subscript, you have 2. And for oxygen, you have 1 from H2O and you have 2 from CO2. Right. So as you can see, you have 2 oxygen atoms in the compound CO2 plus 1 oxygen atom from H2O. So 2 plus 1, you have a total of 3 oxygen atoms. Now, let's proceed to the tips given to us. What tip are we going to use? Tip number 1, try to balance big formulas first, or tip number 2, if the same polyatomic ions appear on both sides, we're going to treat it equally as 1. Is there a polyatomic ion in the chemical equation? No. Since there are no polyatomic ions present in the equation, then let us proceed to tip number 1, and that is to try to balance the big formulas first. So how do we know which of them are the big formulas? So we have to look for the element that has the highest number of atom. So which element has the highest number of atom? Yes, it is hydrogen. Hydrogen has the highest number of atom with a number of 4. So we're going to start balancing with hydrogen first. However, the question is, hydrogen in the reactant side has 4 atoms and the hydrogen in the product side has 2 atoms. How are we going to balance them? How are we going to make them have the same number of atoms? We are going to do some adjustments in the product side. We multiply it by 2 for it to have the same number of atoms with the hydrogen in the reactant side. After multiplying by 2, we will place the number 2, coefficient number 2, before the chemical formula H2O. But remember, H2O is a chemical compound, which means not only is hydrogen affected, but also oxygen. So what happens to oxygen now? This will become, oxygen will become 2. Oxygen will have 2 atoms instead of 1. So if we're going to add it again, 2 plus 2, 2 oxygen atoms from H2O plus 2 oxygen atoms from CO2, then you will have 4 instead. 4 atoms instead. Right. However, then again, oxygen in the product side and the oxygen in the reactant side don't have the same number of atoms. So how are we going to balance them again? This time, we are going to do some adjustments in the reactant side. How? We will multiply 2 by 2 again to have the same number of atoms of 4. This time, both oxygens are now equal. Since we multiplied our oxygen in the reactant side by 2, then we will place number 2 right before the chemical formula O2. Now, the question is the chemical equation balanced? Yes. Why? Because we have the same number of atoms. Carbon, both have 1. Hydrogen, both have 4. and oxygen both have 4. So there you go. This is the balanced chemical formula. Let's proceed to sample number 2. We have the chemical equation H2O yields H2 plus O2. Now, the first things first, we're going to list down all the elements present in the chemical equation. We have H, we have O. In the product side, we also have H and we also have O. Next thing that we're going to do is to count the number of atoms present in each element. Starting the reactant side, according to the subscript, we have 2 atoms of hydrogen, and for oxygen, we only have 1. For hydrogen in the product side, still according to the subscript 2, we have 2. And for oxygen, we also have 2. Now, which of the tip do you think is the most helpful? For tip number 2, it's not applicable because we don't have polyatomic ions present in the chemical equation. But tip number 1 could be helpful instead. So, how do we find the big formulas? We will identify which element has the highest number of atoms. So, which element has the highest number of atoms? Actually, we have hydrogen and oxygen. However, another however, which element has not been balanced or is not balanced? Obviously, that element would be oxygen because in the reactant side we only have 1 and in the product side we have 2. So how are we going to balance them? We are going to multiply the oxygen and the reactant side by 2 for them to have same amount of atoms. Since we multiplied it by 2, we will place the coefficient 2 right before the chemical formula H2O. However, H2O is a compound. So what happens to hydrogen? Hydrogen is also affected. So instead of only having 2 atoms, then hydrogen will have, remember, it has 2 atoms according to the subscript, but it also has 2 molecules. So this means that 2 times 2, then you will have 2 times 2, then you will have 4. Now, we are facing another problem yet again. The hydrogen this time are not balanced. How are we going to make to let these two elements reach the same amount of number of atoms? We multiply the hydrogen in the product side by 2, so they would have the same number of atoms of 4. And we will place the coefficient 2 right before before H2. Now, the question is the chemical equation now balanced? Yes, because hydrogen in both sides have the same number of atoms, and that is 4. And oxygen in both sides has the same number of atoms, and that is 2. We have another equation of BaCl2 plus Na2SO4 yields BaSO4 plus NaCl. Now this time, let us watch carefully or examine carefully the chemical equation. Is there a polyatomic ion present in the chemical equation? Yes, there is. And what is that? That is SO4. We have SO4 in the reactant side, we also have SO4 in the product side. So where is SO4 found in the table? We have sulfate. Yes, it is found here. SO4 sulfate. So since we have polyatomic ions found in both sides of the reaction, then what tip do you think is the most useful? Then we are going to use tip number 2. If the same polyatomic ions appear on both sides of the equation, it's usually okay to treat it as one. Right, since we already identified what tip to use, let us proceed to the next step, and that is to we have to list all the elements present in the chemical equation. Right, so we have Ba, we have Cl, we have Na, and we have, remember, we are treating SO4 as one equation, so we are going to write it as SO4. Same elements are found in the product side. We have Ba, we have Cl, we have Na, and we have SO4. Okay, now, the next step that we're going to do is to count the atoms present in each element. For Ba, how many atoms are there? We have 1. For Cl2, according to its subscript, it has 2 atoms. For Na, according to the subscript, it has 2. For SO4, remember we're treating it as one unit and there is only one SO4, thus there is only 1. Right? Because we're treating it as one unit, SO4. Let's proceed to the product side. How many Ba are there in the chemical equation? We have 1. For Cl, we only have 1. For Na, also 1. And for SO4, since we are treating it as one unit, there is also 1. Now, talking about the tip number 2, since we have polyatomic ions, so the SO4 polyatomic ion should be our priority when balancing. However, SO4 is already balanced. So what's the next step that we're going to do? We will look for the big formula. We will go back to tip number 1 because tip number 2 cannot be applied anymore because it is SO4 is already balanced. So we will go to tip number 1. Look for the elements that has the highest number of atoms. So which element has the highest number of atoms? We have Cl and we have Na because they have the atomic number of 2. And 2 is the highest in this equation. Okay. Now, it's quite a problem because we have a tie. We have a tie because Cl and Na are big formulas. So which element are we going to balance first? Well, it just depends on you. You can start with Cl or you can start with Na. It depends entirely on you because same answer will be the results. Okay, let's try. I want to start with Na instead of Cl. So I'm going to start with Na. For Na to be balanced, because Na in the reactant side has 2, while in the product side it only has 1, for them to have equal number of atoms, I will multiply the Na in the product side with 2. Thus, I will have 2 atoms. Since I already I multiplied Na in the product side by 2, I will place number 2, coefficient 2 before NaCl. And remember, NaCl is a compound, so this means that Cl is also affected. So what happens to Cl? Instead of only having one atom, we multiply it by 2 and we will have 2 number of atoms. So, is the chemical equation balanced? Yes, because we have the same number of atoms present in each element. We have 1, we have 2, and we have 1 for SO4. Let us proceed to the fourth chemical equation problem. We have KClO3 yields KCl plus O2. So first things first, let's examine again the chemical equation. Do we have a polyatomic ion present? Yes, we have, and that is ClO3. ClO3, we can see it here. We have the chloride, ClO3. However, tip number 2 says if same polyatomic ions appear on both sides of the equation, both sides. But as you can see, there is no ClO3 in the product side. So tip number 2 is not applicable. Okay? So we won't treat ClO3, a polyatomic ion, as 1. Since we already identified that tip number 2 is not applicable for this, then we will have to go on and list out all the elements present. So we have K, we have Cl, and we have O. Same in the product side, we have K, we have Cl, and we have O. Next step is we're going to count the number of atoms present in each element. So for K, we have 1. For Cl, we have also 1. For O3, according to the subscript, we have 3. And let's proceed to the product side. For K, still you only have 1, Cl1, and for O2, according to the subscript, you have 2. Now, which of the element has the highest according to tip number 1? Let's look for the big formula. Which of the element has the highest number of atoms? That would be oxygen because it has the highest number of atoms of 3. Now, how do we balance oxygen? If we're going to tackle on huge numbers, it's best to look for their LCM, the least common multiple. So for 3, the least common the multiples that it has is we have 3, we have 6, and we have 9. For number 2, we have 2, 4, 6, and 8. Now, which of the numbers has the least common multiple? What is the least common multiple? So we have here 6, and we also have here 6. So, in order to balance the 2, we need to find a way for them to reach 6. In order for them to reach 6 atoms. So how are we going to do this? In the reactant side, we are going to multiply 3 by 2 for it to reach 6. And we are going to multiply 2 by 3 in the product side for it to reach 6. Don't forget to place the coefficients right before the chemical formulas. We have 2 here, and we have 3 in O2, right before O2. Now, let's go back to the reactant side. As you can see, KClO3 is a compound. So this means that K and Cl are also affected. So what happens? So K will be multiplied by 2 and will have 2 atoms. Same with Cl, and it will attain 2 atoms. Now, K and Cl is not balanced. So what are we going to do? We will multiply also K with 2 for them to be balanced. Since we multiplied K by 2, we will have to place the coefficient 2 right before KCl. And remember, KCl is a compound. Thus, Cl is affected, then we will have Cl to be multiplied by 2 and we'll have the same number of atoms. Now, is the chemical equation balanced? Yes, because we have the same number of atoms present for K, for Cl, for oxygen. Right, so let us proceed to the last sample problem of balancing chemical equation. Let us examine again the chemical equation if we have polyatomic ions present. And we have nitrate, NO3, in the reactant side and NO3 in the product side. NO3, also have NO3. Since we have C polyatomic ions present in both sides of the equation, the step number 2 is helpful and will be applied in this chemical equation. Right, so let us proceed to writing the the elements present. We have Pb, we have Na, we have I, and we have NO3. Same elements are found. We are Pb, Na, I, and NO3. Next step, we are going to count the number of atoms present in each element. So we have Pb, we only have 1. For Na, we only have 1. For I, we only have 1. And for NO3, remember, we're going to treat NO3 as one unit. However, right beside NO3, there is a subscript of 2, which means there are 2 NO3s. So we will place the number 2 here. Let's proceed to the product side. We have Pb, only 1. According to the subscript, I has 2. For Na, there is only 1. And for NO3, there is only 1. Now, we're going to prioritize polyatomic ions since we're going to use tip number 2. And polyatomic ion NO3 is not balanced. So what are we going to do? We'll do some adjustments in the product side. We multiply it by 2 for them to reach the same number of atoms. And since we multiplied it by 2, we will place the coefficient 2 right before the chemical formula. And remember, NaNO3 is a compound. That's why Na is affected. And that's why we will multiply Na by 2. And Na now has 2 atoms. However, Na is not balanced with the Na in the reactant side. So what are we going to do? We are going to do some adjustments again in the reactant side. So we will multiply Na by 2 in order to get the same number of atoms. Since we multiplied it by 2, we're going to place the coefficient 2 right before NaI. Then again, NaI is a compound. That's why iodine is affected. So we have to multiply iodine by 2 to have 2 atoms. The question is the chemical equation balanced? Yes, because we have here the same the same number of atoms for each element. 1 for Pb, 2 for Na, 1 for I, and 2 for the polyatomic ion NO3. So I hope you learned something from our discussion for today, and be sure to familiarize yourselves with the polyatomic ion chart and with the extra tips. Always go back to the extra tips because it can help you greatly easily solve the balancing chemical equations. If you can, please secure a hard copy for the polyatomic ion chart. So I think that's it, and thank you for listening to the discussion.